last video that we're doing for this homework. It's objective 1 day 2 and it's problems 6 through 8, which are these problems here where you're interpreting graphs. And the answers that you should have gotten were A for 6, C for 7, and A for 8. So let's go over the ones that you missed. And I want to change my pen color, but it won't let me. Green. Okay, so number 6, the graph below represents Cheyenne's bicycle trip from her house to a friend's house. On which segment of the graph does it appear that Cheyenne was riding her bicycle at the slowest pace? In class, we did the same graph, but we talked about the fastest pace. I hope that you didn't mix that up and put the same answer that we got in class. So we're looking for slow right now. And if you remember, fast means lots of distance and little time. Okay, so if we're going slow, obviously it's the opposite. It's not a lot of distance and a lot of time. So we need to find the one that has the least distance and the most time. So if I measure these out just like I did in class, okay, we notice once again that U and T have a lot of distance. S has a little bit less, but R has this little itty bitty there. So R definitely has the least amount of distance. If we look at time, you can see here that R definitely has the most time. It's longer than all of the other ones. And so that means that R would be the slowest pace. It's the least amount of distance and the most amount of time. Number 7 says, Paul fills a bucket shaped like a cylinder with water at a constant rate. As he is carrying the bucket, he trips and spills half the water. Paul then returns to the faucet and refills the bucket at a constant rate. Which graph best represents the height of the water in the bucket as a function of time? So they're measuring what this height is. And so every space or place on this graph has to tell us how high the water is at that precise moment. So we can label our axes. This would be time on all the x-axes. And the y-axis would be amount of water. Or the height, it doesn't really matter, because water is flat at the top. Okay, so we have these 4 graphs. We need to figure out which one makes the most sense. And it says he fills a bucket shaped like a cylinder. It really doesn't matter what the shape is. We just know that he's filling a bucket at a constant rate. So if we start with an empty bucket, which we assume it's empty, and we fill it up so the amount of water increases, A makes sense. B doesn't make sense because he's starting with water already in the bucket and then he doesn't change the amount of water, so that totally doesn't make sense. The other 2 are the same as A, so they both make sense. Okay, so now we look at the next clue. As he is carrying the bucket, so when he's carrying the bucket, what's happening to the level of the water in the bucket? Well, if he's not filling it and he's not spilling it, then that level of water in the bucket has to stay the same for at least a short period of time while he's carrying it. So here we have where it stays the same. Here we have where it stays the same. This one doesn't stay the same, so that doesn't work. Okay, so then the next clue is he trips and spills half the water. Well, if you look at this first one, here's him tripping and here's him spilling, but he spills all the water in this example because it goes all the way back to having 0 water. This one is approximately half, and I think actually maybe it should go a little farther down, but that's okay. This is the closest one so far because it goes down halfway. Okay? So then Paul returns to the faucet. So what happens when he's returning to the faucet? The water level doesn't change, it stays constant, just like when he was walking with the bucket. And then the last thing is that he refills the bucket. So we go back up to that same height that we had before. So that's why C makes the most sense for that one. Okay, and then the last one, 8. Identify the graph that best represents the relationship between the number of gallons of gasoline Mr. Johnson purchased at $1.49 and the total cost of his gasoline. Let's rule out the real obvious ones first. He's buying gasoline. It's somehow magically $1.49 per gallon. And I want to know how much is his total bill as he buys more gallons. So C doesn't make any sense because that's saying that if you buy more gallons, let's say 10 versus 1 gallon, you're paying the same price. So if you buy 1 gallon, it's $1.49. And if you buy 10 gallons, you're still only paying $1.49. In that case, I'll fill up my whole car for $1.49, which is obviously not possible. So C doesn't make any sense. D also doesn't make any sense because the total cost of the gasoline is not going to drop as you buy more gas. It's obviously it's going to go up. You're going to pay more for more gas. So D is out. So that leaves us with B and A, both of which go up. The problem with B is that the way that this curve is, that's kind of almost saying that every gallon of gas is worth a different amount of money. So like this gallon of gas might be worth whatever this is, then this gallon of gas is worth maybe a little bit less. This gallon of gas is suddenly worth a whole bunch more because it has more of a rise. This gallon of gas is worth, from whatever this is to this, that's way more money. And this gallon of gas is worth even more, since there's more of a drop right here, if that makes sense. So every time you buy a gallon of gas, there's more of a drop than there was in the last one, which means that every gallon of gas you buy is more expensive. That doesn't make any sense. They're all the same price. So A is the only one that makes sense. If you buy 1 gallon, you pay this. If you buy 2 gallons, you pay double. If you buy 3 gallons, you pay triple, etc. So A is the correct answer.